Uh, Now we will be doing the last part of the physics is long practicals, that's part 6. Here we will do how the calculations is done and how the units are given to the quantities. Suppose one of the equations given to you is t square is equal to a upon b minus h upon b. You are given in this way. Now this equation is given whatever the values of t square are. You are being asked to have a graph of like this one. H is along here in meters and t square is second square, and the line of best comes like here in this way. Now first you will be calculating the gradient here, and the gradient, suppose you are finding I am supposing these values. Suppose the gradient you are finding is minus 2.54 and y-intercept you are finding as suppose 4.84. Now these are the things which you are suppose y-intercept you are finding as suppose 1.324. Now these are the some values, these are just fake values. I just want to make you understand how the calculations are being done. First of all, since along y-axis t square, along x is h, so I will arrange this equation. Y is equal to mx plus c. I can write this t square is equal to minus h upon b plus a upon b. I can write this minus 1 upon bh plus a upon b. Now clearly you can see, if I write again here, y is equal to mx plus c. Along y-axis t square, along x is x. So clearly my gradient m, I will write gradient. My gradient, do not write m, sometimes examples use m, is minus 1 upon b. So I will suppose here minus 2.54 is equal to minus 1 upon b. So minus minus cancels to b is 1 upon 2.54. This is a 3 significant figure. I will write also the value of b in 3 significant figure. This is the calculation. 1 divided by 2.54, and it comes out to be 0.394. I write 0.394. Now it must have a unit. Now what should be the unit? For the unit you will use the equation of homogeneity. Now t square is in secant square, a upon b minus h upon b. If this is in secant square, this entire must be also in secant square. This entire must be on the secant square. So I will write h upon b is equal to secant square. I want the unit of b. This h is in meters. Meters upon b will be secant square. So b comes here. It will be meter upon s square, or it's ms power minus 2. So I will write ms power minus 2. So this is the value of b, and I also give the units. See, the units are given by the homogeneity of the equation. If this equation is carried, it must have the same unit. This is in t in secant square, this must be in secant square, this also must be in secant square. So value of b comes out to be 0.394 meter per second square. Now I have to calculate the value of a also. Now you can say a upon b is equal to y-intercept, or 1.324. So a will be 1.324 into b. So a will be 1.324. I have calculated the value of b 0.394, and a will be 1.324 into 0.394. It is 0.521 or 0.522. 0.522. What should be the units? Now I have seen that units of a upon b must be secant square. I have to find the units of a. So units of a will be s square into units of b. So this s square, units of b is ms power minus 2. This cancel out. So units of a are meters. So I will write 0.55522 meters in this way. So these are, but the units are must. See, I just find t square is equal to a upon v minus h upon v. Here I come, this is the gradient and this is the y-intercept, we found it, suppose from the graph. Now you have to just compare it with y is equal to mx plus c. Now when you compare with y is equal to mx plus c, t square and y are along y-axis same, h and x. So gradient is equal to minus 1 upon b. Gradient comes out to be minus 2.54 is equal to minus 1 upon b. So b is 1 upon 2.54 or this one. Now what are the units? Units of b, I will go for the homogeneity. This is in second square. This entire must be in second square. This should also be in second square. So h upon b second square means unit of h is meter upon b second square. So b comes out to meter per second square or ms power minus 2. Again this one, this is the y-intercept. So y-intercept a upon b 1.324. So a is 1.324 into b. The value of b we have already calculated 0.394. So this is 0.522. What are the units of a? See, units of a upon b must also be second square. So units of a will be second square into units of b. Units of b are meter s power minus 2. So s power 2 and s power minus 2 cancel out the meter. Take another example. Suppose, take another example. I will be giving you three examples. Suppose in the case of the pendulum, suppose these are just supposed values. This is in t square in second square, and this is L in meters. And suppose the equation given is this one: t square is equal to 4 pi square upon g L plus k. And it has been calculated, gradient has been calculated as 3.98. Suppose gradient has been calculated 3.98 and y-intercept has been calculated as suppose 0.526. Now these are supposed values. This cannot be according to practicals. Suppose now he says find the value of g. You have to find the value of g and k. So when I compare with this one, t square is equal to 4 pi square upon g L plus k. When I compare with y is equal to mx plus c, along y-axis is t square, along x-axis is L. So clearly this 4 pi square upon g is m, or I can write gradient equal to 4 pi square upon g. I have to find the value of g. So g will be 4 pi square upon gradient and calculate the value of g. So it's 4, value of pi is 3.142 whole square divided by gradient is 3.98. I don't know the value of g will be coming right or not, or whatever the value of coming. It's just a supposition. 4 to 3.142 square divided by 3.98. 4 pi square upon g, 4 pi square upon g, and this 3.98. So let us see the gradient 4 pi square upon g. It is 4 into pi square and divided by 3.98. The value is coming to be 9.90. Right, 9.92. Now what about the units? If you have units used SI unit, then do not, if it is a general term, if it is a G, then it write meter per second square. Do not need to calculate, but if you want to calculate, you can. You can see here that T square is equal to 4 pi square upon GL plus K. So if the units of this is secant square, the units of this must also be secant square. So I can say 4 pi square upon GL is in secant square. So I have to find the value of G. 4 pi square no unit, unit of length is meters upon units of G must be equal to secant square. G comes here. So units of G will be ms power square or ms power minus 2. So you can calculate by the homogeneity of the equation and this value. Then what the y-intercept? Clearly the y-intercept is k. So the value of k will be coming as how much? 0.526. What will be the units? The units is clearly, since this is in second square, K will also be second square. So in this way, we can find, we can calculate the values from the gradient y-intercept. We can calculate the values and we can assign the units. Take another example. Suppose I have been given this equation, y upon I is equal to rho upon AL plus K, where V is potential difference, V is potential difference, I is current, rho is any constant, and you know it is the resistivity, and A is cross-sectional area, and K is a constant, any constant. So let us see, and if you are asked to plot a graph of this one, this is L meters here, and this is V upon I in ohms. Ohms are, you can say, volt per ampere also you can write. So this has been given like this one. Now suppose the gradient of this, the gradient of this is coming like this one. This equation is given in the circuit, and you plot this one, V upon I ohms and L in meters, and you have a wire whose diameter you are finding is 0.200 millimeters. A is the cross section area. Now first you will calculate, suppose A. So A is coming to be pi d square upon 4. So pi upon 4 into 0.200 into 10 power minus 3 meter square. So this will be coming in meter square. So area coming out to be 3.14 into 10 power minus 8 meter square. Area is, you calculate area this one. Now you find the gradient is suppose 0.502, and you find K as 4.92. Now you have to find the value of rho resistivity, the rho resistivity, and K. So if you compare this equation, V upon I is equal to rho upon AL plus K. With the equation Y is equal to mx plus C. You see along y-axis V upon I, along this one. So gradient is rho upon A. So I can say rho upon A is equal to gradient. So rho will be gradient, value of the gradient is 0.502 into A. A has been calculated as 3.14 into 10 power minus 8. So if you calculate this, 0.502 minus 8, it's 0.502 into 3.14 exponential minus 8. It is coming as 1.58 into 10 power minus 8. Now what will be the units? If you, I have used the SI unit, and if you know this is a resistivity, you can write down directly ohm into meters units. But if you work with the units, you can work. For example, you can write V upon I is equal to rho upon A into L. Now this V upon I is always volt per ampere. This is meter. This is rho, units of rho, and this is meter square. So you can, and L is in meter. This cancel out. So rho will be meter into volt per ampere. This is also correct, but you know volt per ampere is ohm, so I can write meter into ohm or ohm into meter. It's up to you. So you can see it's ohm. You can calculate it this way from the gradient, and clearly the y-intercept is 4.92. So I will say the y-intercept gradient is this, and not the case. Suppose C y-intercept. Y-intercept is 4.92, so it is equal to k directly. So I will write k must be equal to 4.92. Its unit will be units of V upon A, which is ohms or volt per meter. This one. So in that way, we can calculate the things for the gradient and y-intercept. Always the units are given. Units should be always given by the homogeneity of the equation.